In this video, we demonstrate the core of the FRASS approach, integrating biometric and econometric forecasting, with its focus shifted to an extended time horizon. Linear and sequential quadratic programming are used as tools to find the highest asset value combinations, analyzed through multiple rotations on each timber stand. The effects of time for biometrics and economics are carefully considered and methodically integrated into the financial optimality structure. We will demonstrate how combining biometric and econometric projections into a unified scenario increases long-term profitability through strategies of land management activities. Traditional economic analysis techniques in forestry focus on optimizing the current timber rotation, with subsequent rotations added after the current one is harvested, thus diminishing the importance of the time value of money. FRASS takes an alternative approach to harvest timing strategy by shifting to longer time horizons with multiple rotations on each timber stand, demonstrating a significant increase in the financial value of long-term asset returns. Vast datasets accumulated through complex mathematical algorithms and stored in a big data vault become accessible for targeted business decisions to maximize profitability. Beneficiaries of the system include financial officers, asset valuation specialists, accountants, forest managers, and land appraisers, all sharing the same data clusters. The FRASS approach begins by calculating prices and costs to match volume predictions by sort on each timber stand annually for 10 years, then every 5 years for 250 years, using the same approach for the next rotation and every subsequent rotation into perpetuity. Future values displayed as arrays of harvest timing solutions are discounted to present-day terms, with the highest net present value combinations revealed. Now we will talk in more detail about how this difference between the traditionally accepted approach to timber valuation versus the FRASS approach is realized in practice, using for this purpose a timber stand selected from our demonstration site. In the traditional approach, techniques to determine harvest timing are tied to the current rotation. Timber growth predictions are combined with current prices and costs to schedule harvest dates with financial maturity in mind. The value of subsequent timber rotations is added after the current rotation is completed. Future values are discounted to net present value, and a total asset value is generated as a result. We will look at our timber stand's discounted present value while applying traditional approach techniques. In FRASS, users create delivered log market and RPA portfolios to be applied to parcels through this screen. Pulling down the RPA portfolio menu, we see all portfolios in the profile, plus an option of No RPA Portfolio, which we're going to select for the demonstration, and click Apply Market Model with RPA Portfolio. The View Stand Report button takes us inside the workings of the program. Examinations of these screens are not required when using the program. They are available to show how harvest timing trade-offs impact financial returns. We select the timber stand identified earlier and click View Stand Report. The first screen shows the Rotation 1 summary with species and sorts arranged on the left, the years of analysis as column headings starting in 2014 and extending 200 years into the future in 5-year intervals. Future net values are summarized by sort. At the bottom of each column, the values are considered in the context of timber stand size and additional costs, discounted to net present value. The highest net present value is identified as the single rotation optimum on the stand. On this single rotation report, the financially optimal harvest is scheduled in the year 2040. When the NPV Max hyperlink is clicked, a net present value chart displays the stand's financial growth and decay pattern. The traditional asset valuation approach considers subsequent timber rotations in a series known as the soil expectation value to determine repeated rotation cycles into perpetuity. FRASS does calculations through the perpetuity screen generating a 60-year rotation schedule as financially optimal for this timber stand. We are looking at a single rotation solution in 2040 for rotation 1. Rotation timing of 60 years into perpetuity sets the duration for rotation 2. When all values are combined, the net present value of $379,488 is identified for this timber stand. That is how setting harvest timing and calculating asset value are conducted using the traditional approach. The FRASS approach integrates an extended time horizon as a critical dynamic in the process of analyzing complex data structures. Harvest timing options for each timber stand are based on synchronicity of a current rotation considered in concert with the next rotation, and after that, every subsequent rotation into perpetuity. This harvest event sequence, when looked at as a set of analytical steps through time intervals, brings into play a mix of temporal transformations in multiple combinations of log, quality, and value. Lengthening or shortening the duration of one rotation will delay or advance the value of the next rotation and the optimal value of the entire series. In FRASS, calculations of net present value consider 1,600 possible rotation length combinations, extrapolated into the future as a harvest event sequence on each timber stand. Growth and yield projections, price and cost forecasts, with inflation rate and landowner-specific discount rate, are combined in a comprehensive financial package of interrelated quantities guided by the power of time. Now we come back to the parcel analysis control page. At the RPA portfolio menu, we make our selections and click the Apply Market Model with RPA Portfolio button. This page shows all prices and costs, created and applied, which can be changed at any time to test projected value sensitivity for minor or major changes to portfolio settings. We select the timber stand we viewed earlier and click View Stand Report. The Rotation 1 tab automatically displays pieces and sort volumes combined with RPA forecast tool price projections, cost expectations, and road use expenses today and in 5-year intervals for the next 200 years. Each future nominal value is discounted to real present-day terms. On this single rotation report, the financially optimal harvest timing is achieved in the year 2040. When the NPV Max hyperlink is clicked, a net present value chart displays the timber stand's financial growth and decay pattern. The Rotation 2 tab repeats the analysis for anticipated timber stand volume, with harvest simulated every 5 years for 200 years, finding the highest net present value combination. Inserting the second rotation between the first and perpetuity rotations introduces a higher level of operational maneuverability when analyzing biological maturity of the stand, combined with its financial value transformation. On this single rotation report, the financially optimal harvest timing is projected at 60 years. Analysis of the third rotation is replicated using the soil expectation value to extend rotations into perpetuity. On this perpetuity rotation report, the financially optimal harvest schedule is 60 years. Combining harvest dates for each rotation through sequential quadratic programming allows us to see the net present value of each combination. Rotation 1 harvest is viewed in 2040, with 200 years of Rotation 2 harvest options stacked in time, to follow Rotation 1 and each Rotation 2 harvest, followed by rotations into perpetuity. The Optimal Combination tab combines harvest options for each rotation into net present value solutions. Looking at single rotation options, we see Rotation 1 harvest in 2040, followed by Rotation 2 harvest after 60 years, and the perpetuity cycles placed at 60-year intervals, each stacked in time to generate a combined NPV total of $485,460. Shortening Rotation 2 from 60 to 50 years increases the total value to $488,660. $600. FRASS demonstrates utmost respect for a time horizon imperative when it comes to ultimate goals of timberland management, and demonstrates why multiple rotations on the same stand are considered in concert. The highest value in this quinquennium is colored green. However, we have not yet taken the final step. Harvest timing combinations for the 3 rotations are stacked through time to discover the ultimate financial optimal combination. This highest value solution is identified and colored red. In this solution, the current rotation is scheduled for harvest in 2025, with the next rotation harvest in 50 years, with all subsequent rotations on a 60-year cycle. On this timber stand, with the economic variables selected, the net present value is $513,623. The optimal solution, just demonstrated, introduces a 15-year reduction to the current rotation length and a 10-year reduction in the second rotation, which creates an increase of $134,000 in net present value, boosting long-term returns by 35%. The difference in results when comparing the traditional versus the FRASS approach, calculated against a broader time horizon of multiple rotations with synchronous and actionable market forecasts, is significant. Harvest timing for both approaches is determined using the same timber stand, the difference being a change in approach, allowing the optimization profile to work on a broader timescale, using an advanced econometric design supported by powerful computing and programming capabilities. In the modern world of an endless quest to achieve economic efficiency, finding the highest long-term asset value promotes itself to the foreground. Utilization of a broader time horizon approach in a vast domain of forestry is manifested in FRASS through multiple rotation analysis and integrated market behavior trends. The effect of such an approach becomes multifaceted and undeniably influences many interrelated factors. The FRASS approach harnesses the power of the time value of money, which cuts through the program's entire conceptual paradigm of financial optimization techniques, such as multiple rotations, the RPA forecast tool, biometric modeling projections, physical site conditions, and spatial analysis, all combined to deliver the harvest timing blueprint to achieve the highest and best use value of each timber stand, parcel, district, and the entire tenure. Leveraged with user-specific big data, managed through our software-as-a-service delivery, advanced econometric design, and sequential quadratic programming, actionable results are generated, leading to increased profitability and streamlined reporting. Contact us at the email shown here to arrange a no-cost demonstration of the program and receive guest access to our fully functional demonstration site. Enter FRASS on your own to explore how it will fit into your financial optimization profile.